All right.
I just don't feel like I did these right.
Did you watch the notes?
And then I
Good, make sure you caught up. Okay, first page. Things I wanted to highlight on the first page. Elemental form is 0. And remember, when oxygen is part of a peroxide, that's the only time it can be a -1. So don't forget, the only time oxygen can be a -1 is when it's part of a peroxide.
What's the rule for hydrogen with metals and non-metals? Are they different?
What do you mean?
Like, is the charge different?
Hydrogen's always a +1.
Okay, because some videos said hydrogen plus and metals are -1.
Well, on this one, it's kind of weird because lithium is always a +1. So on this one, hydrogen would be the acceptor because lithium wants to give away an electron.
Okay.
So, but the vast majority of the time, hydrogen's always +1. That LIH is a weird situation. Yes?
So for the elemental form, I was confused because I thought that S8 was an elemental form because it has 8.
It's 1 because it's just still one single element. So diatomic would be elemental form, S8 would be elemental form, or something by itself.
Now,
If there's just one capital letter, it's elemental
what
form.
about the KMNO4? That
Yes.
How do you kind of go about? Do you work?
Alkali metal is always a +1.
Okay.
Oxygen always a -2.
And then just fill in that middle.
Then fill in the middle. Yes. Then fill in the middle. Save the metal for last.
So it's always 0?
Should've.
Yes, the compound, unless it has a charge, like this one had to add up to -2. If it doesn't say it has to add up to 0. Has to add up to 0. Okay, good with the oxidation numbers. Okay, then we moved on to,
Leave that up there for a second.
I am recording this too, but you can snap a pic. Got it? Okay. On to the half reactions. So the first one, and these are kind of hard to like look at because it's easier to like see the process, I feel like. But you should have ended up with Cr2072- plus 14H plus 6Cl minus yields 2Cr3 plus 3Cl2 minus plus 7H2O.
Are you collecting?
No, I am not. This was just practice on your own last night, getting us ready to do the practical part of what we're going to be doing today. Number 2.
Oh wait, I have one quick question. It's a step that messed me up every single time. So when we're doing the charges
Yes.
and we're adding our electrons,
Yes.
if necessary, do we just take the one? Like, how are we summing up those charges?
We're-
Like for, I don't know, like the second example, we have like NO3 -1, and then like on the other side we have NO, so we just like technically it'd be
So-
-0.
So on this one, I had, before that 2 was there, right?
Just be -1.
It'd be a -1. And then I had 4 positive,
Okay.
right?
That's what I thought, yeah.
So 4 positive plus 1 negative is 3 positive.
But on the other side, the NO and the HO don't contribute.
There's no charge.
Okay, so I thought.
So in order to make no charge, I had to add 3 electrons. So you're always adding electrons to make it equal the other side. Whether that's 0, there could be a charge, but you can only ever add electrons. You can only ever add electrons.
Where'd you get 4H2O from?
From where?
I see.
Okay. Like I said, these are a little bit difficult because you can't see the process.
Yeah.
But we just don't have time to like go through all these individually. Number 3 is down here. So number 3, I ended up, you had to add 2 OH minus because we needed basic conditions. So I ended up getting PbOH4 2 minus plus ClO minus yields PbO2 plus Cl minus plus H2O plus 2 OH.
I have a question about the acidic and basic.
Yes.
So those mean that that's how it has to be at the end.
Correct.
Right? Okay, it's not like the condition that's happening.
It doesn't matter how, it doesn't matter until the end.
Okay.
If it's acidic, you have to end up with
End up with
H
one
plus.
and then if it's basic.
If it's basic, you have to end up with OH minus. You got it. So that was number 3. And then numero 4. I don't know. I think I redid it. I restarted down here. Or no, what did I do? So this was the original. I split it into 2 half reactions. Then I need to zoom out a little bit so we can get the whole thing on here. I accidentally was doing this as an acid because this was basic. And then I realized I needed to add the OH minus. what you ended up getting was 3CN minus plus 2MnO4 minus plus H2O yields 3CNO minus plus 2MnO2 plus 2OH minus. So that was the half reactions. Any other specific questions on those? Okay, cool. Then let us move on to the practical part of what we're going to do with this. So, here we go. So we left off here, and we know that electricity can either cause a reaction or can be produced by a reaction. So one thing I wanted to highlight in here was that spontaneous reactions occur, and you split them up. Guess what I want to highlight in this paragraph? There's one thing I want to highlight. Not standard conditions, but that is important. A salt bridge must be applied to replenish ions to both sides of the cells.
So if Mr. Oler is like inside on the AP exam, he knows there's going to be a salt bridge question.
Well, there has been in the past. I just that would be something that I really wouldn't want you guys to miss. That's why I hit it so many times. So we have big fat red cat, anox, because we have at the anode is oxidation, all the different ways to remember your anode ox, your cathode is reduction. Big cat means the cathode does what? Gains mass. Fat cat means the electrons are moving from anode to cathode. Red cat means what's happening at the cathode? Reduction. And then this equation, E cell equals E cat minus En. We're going to be using that today. Flip it. So here we go. So this is our first actual half cell that we have ever seen. This copied not great, but it's okay. Can you guys tell that this says Cu and this says Ag on yours? Okay. So how would you do something like this? Well, first of all, it's telling me that the electrons are flowing this way. Agreed? Yes? And we know that there is always a fat cat, right? And this is showing that the electrons are flowing from the anode to the cathode, which means that my silver is my big cat. That's my big cat, which means my silver is going to do what? Going to gain mass, right? So this one should be gaining mass, and it's also my red cat. It's also my red cat, which means there's reduction happening at the cathode. Over here, that means that my copper must be doing what with mass? Losing mass. This is losing mass. And what occurs at my anode? Oxidation, right? Oxidation is occurring at my anode. The half reaction for each one of these. So, copper is losing electrons. Yes? So I would write that half reaction as copper yields Cu plus 2 electrons. So if it's losing electrons, electrons are going to be in the products. Does that make sense? Because you're giving them away?
How did you determine how many?
Because it's a plus 2. Because it's a plus 2, it's going to be Cu plus 2 electrons. Over here, what am I going to write for my half reaction? Ag plus what? Plus 1 electron. Agreed? Because it's silver plus 1. And this is gaining, so I show gaining by putting that in my reactants. That makes solid silver. If they would have just given me this, how would I have figured out what the anode and what the cathode was?
How many E minuses are on the left? Well, you can tell from the that collective product and reactor side where the electrons.
I can tell from where the electrons are flowing, or open your book to page A26. Open your book to page A26. You can just scooch over. What? Okay, it's fine. So I'm on page 826. I'm just showing this what this looks like on this video.
You need to have a positive delta V value, the differential between them, right?
The way I know, good save. The way I know which one is reduced is what? So I'm gonna make a note. Let's make a note. Oh my gosh, stuff is just falling everywhere. All right. We're on page 826. So I'm gonna make a note of that here. We know that the more positive the voltage, we've talked about this, this is the third time I think we've said this, the more likely it is to be reduced. So I'm going to look for these half reactions. So I have copper 2 plus. Copper 2 plus. When I look up the copper 2 plus, it's 0.34. Agreed?
Yeah.
Yes? So I have 0.34. So just take a look at that. And then don't write anything down yet. I also have silver plus 1. Silver plus 1 is what? 0.80. So which one of these is being reduced? Silver, right? Because it's more positive. Now, the tricky thing is, right? This is the standard reduction potentials. Agreed? So that copper plus 2, what does that equation, what are we going to do to that equation eventually with the voltage? This would be if this was being reduced. Agreed?
Yeah.
But in our reaction, what's copper being, what are we actually doing to copper? So what would I have to do to this equation?
Flip it, so negative.
So this actually becomes negative, yes. So that's something else to watch out for. Something else to watch out for. So that's where they got these numbers. So I have E cat minus E an. So 0.8 minus 0.34, that's how they got the 0.446 volts. Are you guys okay with that? Yes?
Why is that? Wouldn't it be double negative or no?
If you just leave it, so without changing the sign, this will still work. E cat minus E n. So you could potentially have minus a negative if I would have had one of those towards the bottom right on that chart. So don't change the sign if you're just going to use this equation. Okay? Then we have Gibbs free energy. So delta G is negative 2 moles. How do I know 2 moles of electrons is moving? Because I have 2 electrons. Times Faraday's constant times 0.46. And remember that a joule per volt is equal to a coulomb. So make note of that. A joule per volt is a coulomb. So this is one way to figure out the voltage. I'm going to show you how I like to do it. Because a lot of the times they're going to ask for like the balanced version of these two half cells. So here's how I like to do it. I like to do it like this. So I'm going to start out with my, doesn't matter where you start out, Ag plus 1 electron. That gave me Ag. Yes?
Yes.
What was the voltage for that?
0.8.
0.80 volts. My other equation was Cu yielded what?
Cu plus 2.
Cu plus 2
Plus 2
plus 2e
E minus.
minus. And what I like to do when I'm down here is I like to add these together. So if I'm adding, guess what I'm going to do to my voltage down here? I'm going to flip it to a negative voltage because I know that this one is the one that's being oxidized. So I'm going to make this a negative 0.34 because I'm going to be adding these together. Does that make sense?
You have to like double the top one.
You're right. So Jawei sees that my electrons aren't balanced. Agreed?
Yeah.
So this is going to be 2Ag, this is going to become 2 electrons, and this is going to become 2Ag because that balances out my electrons. So if I was going to write out my overall balanced equation for this, it would be 2Ag plus Cu yields 2Ag plus Cu plus 2. And what's my overall voltage? Add these together. We already know.
Double the volts.
Oh, yeah.
You don't double the volts. The volts do not double. The voltage stays constant because you're changing this all proportionally.
Okay.
Yeah, it's going to be 0.46 volts. So that's why, this is how I like to do it, because you get the voltage and you get your balanced equation. And you get your balanced equation.
Wait, where did the electrons?
They cancel out because I have 2 electrons on this side, 2 electrons on that side. The last thing that we could do up here is we could write a short form.
Oh, shoot.
What would my short form look like for this? What would be on the left?
Cu2 plus slash
Cu slash
C2 plus.
Cu2 plus slash slash
I don't remember.
Ag plus slash Ag. And it's always the solid plus the ion, salt bridge, ion, solid. So there's a lot that we can do.
Solid plus ion.
It's the solid, the ion, salt bridge, ion, solid. Really, this is solid, liquid, salt bridge, liquid, solid. Because the ions are in the liquid, agreed?
Is the 2 slashes, is that like the common way to represent the salt bridge?
Yes.
Okay.
That's the way to represent the salt bridge. Now, what does my salt bridge do? If I without this, right? If I was without the salt bridge, what would happen to this side? It would become what?
Just run out.
Because it would become too what? Would it become too positive or would it become too negative? What is this side doing?
Oxidizing.
Which means it's doing it with electrons.
Losing.
So its charge is becoming more.
Positive.
This side would become too positive. Agreed? That does not say toot. This side
And that's gaining too many.
would become too negative. So my salt bridge, KNO3, the K is reacting with the extra electrons. The NO3 is reacting with the positive. So that's what the salt bridge is doing. It's making sure that one side doesn't become too positive, one side doesn't become too negative. That's the purpose of the salt bridge. Are we cool with that? Okay. So that was a lot. Flip it. All right. So now we are still talking voltaic cells. So I have a setup. I have Al3 plus as one half cell, and Sn plus 2 as the other half cell. The half cells contain equal volumes of 1 molar solutions and are at standard conditions. So write the balanced net ionic equation for the spontaneous cell reaction. So what would be the first thing we'd have to do here?
Look at the delta V further V.
I would look at their reduction potentials. So I'm going to look at Al3 plus on the chart. So that is what?
It is negative 1.66.
That's negative 1 point. Yes, that's right. That would be negative 1.66.
Yeah.
Agreed? So this one is negative 1.66 from my chart. Are you guys okay where I'm getting that number from?
Yeah.
And then I have Sn2 plus.
Negative 1.4.
That is negative 0.14.
So since
So which one is more positive?
it's going to be the AL. Or
Which one?
SN.
Which one is more positive?
SN.
It's this one,
So it's being
right?
reduced.
So this one is being reduced. That's my red cat. Yes?
Yeah.
So if I was going to write a short form for this right now, how would I write it?
It's going to be
Yep, it'd be Al plus 3 slash
Slash and then SN plus 2
Sn plus 2
and then
Sn. I love that. Because once you know what's being reduced, the thing that's being reduced is always on the. I'm doing it from your view. On the right, yes. Write the balanced net ionic equation for the spontaneous cell reaction. So, my Al, what do I have to do with that reaction?
Lose 3 electrons.
My Al is being oxidized. Agreed?
Yeah.
So what do I have to do with that reaction that they gave me in the book?
Flip.
I gotta flip it, right? Because in the book, that's if these were being reduced. Yes? So I'm gonna flip that, and that's gonna give me AL, right? Yields, AL plus 3 plus 3 electrons. Voltage for that is gonna be, I flipped it.
1.6?
Agreed? So now it's a positive 1.66 volts.
Didn't you say that when we're writing them, like, for the...
When we're doing it like this, you gotta flip it. If you're just doing E cap minus En, you can leave them. We're not doing E cap minus En here, okay? Because I like to do it like this because you get your balanced net ionic equation and you get your voltage this way. Cool?
Yeah.
My other one I'm gonna leave as it is. So my tin is Sn plus 2 plus 2E minus yields Sn. And the voltage on that is negative 0.14 volts.
I think the only thing that confuses me is that when I look at that equation, that makes me think that AL is the cathode. Do you know, like, do you see what I mean? Like, I understand why, but it looks confusing.
After you flip it, is that, you're saying after you flip
Yeah, it
it?
looks
So
like it's a cathode.
it's not, right? The reason we flipped it is because these are the numbers we compared. Yes? We flipped it because AL is the anode, right? All of these are showing if they would have been the cathode. But we found out that AL is the anode, so that's why we flipped it. Are you okay with that, Jack?
Yeah.
Okay. If they're just asking for E cell, just do your E cap minus your En, just subtract them. But a lot of the times they're going to ask for the net ionic equation and the voltage. So this kind of puts them together as one. Electrons are not balanced. On the top, I have to do times 2. So 2, 2, this becomes 6. The bottom, 3, 6, 3. So my balanced net ionic equation, I'm going to put it on the next one because I ran out of room, is going to be 2Al plus 3Sn plus 2 yields 3Sn plus 2Al plus 3. Overall voltage is what?
1.52.
1.52 volts. 1.52 volts. So that's why I like to set it up like this. It really is doing two things at once. It's getting you your net ionic equation, and it's giving you your voltage. Are you guys okay with what we're doing?
Yeah.
Okay. Calculate the value of the free energy delta G for the spontaneous reaction. Well, we know that delta G equals negative NFE. So now I'm going to sub in what I got. Delta G equals negative what? How many moles of electrons moved?
6.
6. Negative 6 moles of electrons times Faraday's constant, which is 96,500 joules per volt moles of electrons, times what? E. What's my E? 1.52 volts. So that's going to leave me delta G in what? No.
Or, sorry.
Joules.
Joules?
Yep, so do it. So what do you get for delta G?
I got 880080. Wait, no. It's negative.
Positive or negative? Because the positive or negative is kind of important.
Negative 880.
Negative 8.80.
Oh, yeah.
Because you guys would agree the only thing I measured was this.
Yeah.
Yes, that's a constant, that's a constant, yes?
Yeah.
So I'm getting my 360 from there. Times 10 to the what?
1, 2, 3, 4, 5.
Fifth joules. Which means, we knew this needed to be negative, right?
Yeah.
Because I got a voltage. Therefore, it is what? Spontaneous. right? If I'm getting a voltage, that means that this is a spontaneous reaction. We know that spontaneous reactions have a negative delta G. Cool? Okay. In another voltaic cell, with an AlL3 plus SN plus 2 half cells, SN plus 2 is 0.10 molar, and Al is 1 molar. Would you expect the E cell to be greater, the same, or lower?
So first problem are equal 1 molar solutions. Would
Don't
that affect
overthink
the-
this.
Would that affect the flow?
Yeah.
So I'm going to presume the cell potential would be,
What do you have less of with a lower concentration? What do I have less of if I have a lower concentration?
electron?
Less ions, right? If I have less ions flowing, I have less electrons moving. Agreed? So if I have a lower concentration, I'm going to have a lower voltage. Because I've got less things moving. I have less things in concentration. So lower concentration is going to make a lower voltage. Okay. Electrolytic cells require voltage and therefore will be hooked up to a power supply. So now I have to plug these in to make these happen. An amp is equal to a coulomb per second. So I'm just giving some equations here. Silver plating occurs, we're going to do this in lab, when electrolysis of Ag2SO4 is used because silver metal is formed at the anode. This is the positive electrode. So the reaction E minus plus Ag is Ag. Recall Faraday's constant says 1 mole of electrons is 96,500 coulombs. Probably Breda. If a cell runs for 200 seconds with a current of 2.250 amps, how many grams of Aj will be deposited? So here's an example of how you would do this. So I have 200 seconds. Obviously it's over 1. You didn't even need to write the 1 there. 1 second is 0.250 coulombs because an amp is a coulomb per second. Do you see how we just made that? We converted that. And then I use Faraday's constant to get to moles of electrons. I know that I have 1 mole of electrons per 1 mole of silver, and 1 mole of silver is to its molar mass. So that's what we're doing. So electrolytic cells, you're usually doing stoic, is what that's saying. On this one, a current of 10 amps flows for 2 hours through an electrolytic cell, which at this point you're thinking, dang it. Why?
Hours.
Hours. We know hours aren't going to help us. We need what? Seconds. Containing molten salt of metal X. This results in the decomposition of 0.250 moles of metal X at the cathode. The oxidation state of X is at +1, +2, +3, or +4. Here's how I set this up. I'm going to start out with my 2 hours. So I'm going to set up with my 2.00 hours. And I know that 1 hour is how many seconds? 3,600 seconds. 3,600 seconds. You could have went hours to minutes, minutes to seconds. That'd be the same thing too. And I know that for every 1 second, how many coulombs of energy am I getting? 10. Because remember, an amp is a coulomb per second. Yes?
Yeah.
I'm getting 10 coulombs of energy. And I know that for every 96,500 coulombs, that is 1 mole of electrons. Right?
Yep.
This last step is kind of tricky. Times. What am I trying to figure out? I'm trying to figure out
How many electrons are lost?
question mark in 1 mole of X. Agreed? I don't know what this number is. Yes?
Yeah.
And they told me that I ended up with 0.250 moles of X. So it's a little bit weird. A little bit weird to solve in the dimensional analysis. But that's what I would do. So solve for your question mark. Tell me what you get.
Oh, so it's just for dimensional analysis divided by 0.25.
Yeah. So it's just math.
Oh, Joe.
There's been a lot of stuff falling this class.
I don't get it like triggers me in the slightest way.
Oh my gosh.
There was one year, I don't know. When have you freshmen with me when I had a Hydro Flask fall counter?
Oh, yes.
Were you, Joey? Yeah, that was 2 years ago. I had one class where everyone had Hydro Flask and they just kept falling.
Oh,
So I just started keeping track because it was like almost, that was the only way I could like stay sane. So we had a Hydro Flask fall counter. We got to like 5 in a period one time.
Earlier, Mr. Knight was just like swinging like
That
this,
was so
freaking,
dangerous.
like
I was not
speakers
for
going
that.
around. And it was making-
Doppler effect?
Yeah, and I was, oh,
Was that for physics or?
that's just for physics.
Yeah.
Please.
Sometime I want to hide that in the ceiling
No.
and like wrap it up in like a towel just so it's like quiet.
What'd you get?
I got
I
2.98.
did not do that right.
You should have got something very close to 3.
Oh, how will we do
Actually,
that?
Multiply the top by the bottom. Or multiply.
I would multiply the top.
by the bottom across.
Okay.
I'd multiply the bottom.
I did that.
And then you're going to cross multiply, right? This times this, right? What if you get on the bottom times this divided by the top? Cross multiply.
Yeah, wait.
And on the bottom, it's just 96500. That's what I got. 7200 times, wait, and then you go 0.250 times the bottom number, 96500 divided by 72. Wait, I'm not doing
How'd you get 72 on?
No, 72.
Multiply straight across,
Yeah.
multiply straight, like across the bottom.
Yeah, I did that in the
Yeah.
last one.
Oh,
So
the
then-
X on the bottom is what it is wrong.
Yeah, and then you divide by 72.
Are we good?
Yes.
Yeah.
Okay. So the answer is your question mark equals 3 plus. It's 3 plus.
Huh?
We got 3, right?
We got like 0.3.
Huh?
Huh? You're doing it wrong.
You should have got like 2.9 something.
That was like what?
You should have got like 2.9 something, very close to 3.
Did you multiply it like, or did you,
We're multiplying the top,
yes?
then what?
Then you divide it by 0.25.
And then what do we do with the 96,500?
Wait, no. You multiply everything by the top, you divide the 96,500, and then you multiply the 0.25. Or then you divide the 0.25. That's what I did.
Charlie, you're talking so fast.
Oh, my bad, that's just becoming big. Hold up. I'll do it slower. So it's 2 times 3,600
Right?
times 10
Correct?
equals
Oh, I
divide
got it. My bad.
96,500
I got 2.9.
divide 0.250.
Right.
Rounds up to 3.
See, I don't know what Charlie's did, but his worked for me.
So multiply the top,
100 billion did wrong.
divide by the 96,500. Agreed?
Yes.
So that gives me something over question mark. Agreed? So that means I have to divide by this in order to flip the equation
Yes.
to get your x. Also, I don't think you would see something like this on the AP test. But it's just kind of fun. It's not that hard, but like, you wouldn't do something like this on the AP test. All right. Solutions of Ag plus, CO2 plus, Fe3 plus, and Ti4 plus are electrolyzed with a constant current until 0.10 moles of the metal is deposited. Which will have the greatest length of time? Which one would take the most time to deposit that metal?
The one with the most electrons.
You got it. It would be Ti plus 4. Because how many moles of electrons? There's 4 moles of electrons. More moles equals more time. More moles equals more time. You got it. All right. I think we can do this one, then we'll call it a day. All right. Do you guys want to try it? I'll give you a 2-minute head start. I'll give you a 2-minute head start.
Not crap.
What's your first step?
Find the
Look at the chart. Look at the chart.
tip and the
I don't have one.
Find the flow of electrons.
The packet may also have the chart. I don't know if the packet has all the ones we need, but the packet had a chart too. Not this packet, our notes packet had that
I
chart.
could read those guys.
Yeah, it was not very good.
No.
ZN, do you see ZN? No.
Yeah, no.
We just did AL plus 3.
No, ALNO3. Oh wait, no.
No. Look at the ions. Look at the ions. I'm looking at AL plus 3 and ZN plus 2.
So that one's 0.76 and the AL.
Chat, are we through? Oh, here it is.
Where?
Ah,
Maggie, I think I've written you a recommendation that guarantees it's so good.
Oh, speaking of
I already-
So-
did you finish the one for the?
Or wait.
wait, so the one,
I
wait,
sent
hold
you.
on. I gotta.
I believe I'm caught up on those. Can you not see on your end when it's done?
The more
I'll check.
Positive is the reduced ones. the
Yeah, more
cathode,
positive,
So the
so the
ZN,
red.
ZN's cathode. And the AL is the anode. Right at the half reaction.
Wayne County Community Foundation, Aubrey?
Which
I don't even see you on my list.
I put you down on.
Because I did one for Brady, Daniel, Maddie, Daisy, Brock, Emily,
reaction takes place at the anode.
Xander. I don't even have you on my list. So I would check that.
Is the left the anode or a
Chad
cathode?
is real. It's an anode.
Wait, so is the left an anode?
It's an anode.
No, because we were writing that to the short.
Aubrey, check it.
Wait, is that what B is?
Oh, the left is the anode.
So
Wait, but I'm trying to write down the.
Guys, where should I go for dinner? Oh, sorry. I'm distracting you. You guys keep going. Dinner tonight.
Somewhere with food.
Does Pizza Hut have a buffet on Wednesday night?
I didn't even know they
I
still
thought
have
they
it.
got rid of
They have a buffet at lunchtime still. It's legit.
AL.
I feel like I'm bad aim.
Oh my
What was
god,
that?
this girl, she just didn't have her mouth guarded yesterday, and I was so surprised that she did not get called for that.
Okay, there's so much more like relaxed about the like technical calls.
So would you
You
get
can have white
AL
mouth
slash
guards.
L3
Yeah,
plus
they
double
didn't
slash
like, they didn't
GN
give
2
her
plus
yellow card
plus
for having her ears.
GN.
I know, like.
Oh, yes,
They
that's
had
right.
yellow
I've
card
seen
for
them
having
right
a
there.
bracelet on. They didn't give another girl a yellow card for having a bracelet on.
They should have.
You can have white mouth guards.
So the half reaction taking place at the cathode is just gonna be, can't remember which way.
The cathode stays. Remember, the cathode stays because these are reduction potentials.
So it's just gonna be ZN.
The anode has to flip.
So it's ZN is ZN 2 plus 2 electrons. The anode's gonna be AL 3 plus 3 electrons.
Grant,
No?
the anode, you have to flip it.
Yeah, I did. Wait a
So
minute.
it'll be AL.
Correct. Yes. Yes.
So I flipped.
Okay, yeah.
Remember, these are reduction potentials.
No, the cathode's.
Cathode stays.
Chat, what are we?
ZN 2 plus 2 electrons.
Correct.
I feel like I'm selling right now.
Like that? Yeah,
Huh?
Yeah.
okay.
Right up the bouncing around
Oh,
equation.
okay.
Okay, here we go.
I'm looking.
This is
Next week.
what?
I turn 18 next week.
Awesome. This is not bad, guys.
No.
I feel like
It's a little bit of like thinking.
it's a little bit of thinking, but I also feel like I teach this pretty well.
I hope I did that right.
I bet you did.
AL yields AL 3 electrons and multiply by 3. Multiply by 2.
Yes.
Three
I
Z
literally,
two
we
plus
leave on my freaking birthday, and I'm like, bruh.
2 AL.
I'll give you a birthday cake for the bus.
2 AL 3
How
plus
far away is it?
plus 3 GN.
And
And do
then
the
Kylie
thing.
turns 18 the next
So-
day.
I got
So
you.
the ZN
No.
is negative
Oh,
0.76.
okay, yeah.
And then we're flipping that value, so it's gonna be plus 1.66.
I like what I'm hearing.
Oh, crap.
Deanna is
They want,
getting
I did the whole thing, but they only wanted
Oh, I
part.
haven't been ready.
Wait, so which one's the cap? Oh.
0.89.
Oh.
Question mark, did anyone get that?
Okay, like, I wrote the three. What is the?
So which metal's gaining mass? It's gonna
So
be
probably 4 hours.
Zn.
I'm making sure that everyone-
Math the balance.
Are we taking
It's, we're not.
What did you miss?
All right, here we go.
Wait 1 second.
Okay.
Identify species that's being oxidized. So that is going to be the anode, which, okay, all right, done.
We got it? Which metal's the cathode?
The
Zinc.
Zn.
Because it was more positive on the chart. So I labeled cathode, I labeled anode, I drew arrows, so I knew which way the electrons were flowing. Just helps me visualize it. Half reaction at the cathode stays the same from the book. Yes?
Do we need to tag the voltage on?
What do you mean? I just did because I know I'm going to need it later.
Okay.
Because I know I'm going to need this voltage down here, 0.76. I know I'm going to need this one down here, 1.66. What's the anode? The other one, aluminum.
Yeah.
The anode has to give up electrons, right? So electrons have to be a product. So I flipped that equation,
That's why that is, okay.
right?
So since they're giving it up, it's gonna be on the product.
Correct. The anode has to give up. They're going to be on the product side.
Making sense.
Good. Write the balance in that ionic equation. So here are my two equations. In order to balance this, I have to multiply by 3. This becomes a 6. 3, 2, 2. That becomes 6. Add those up. So I have 3Zn plus 2 plus 2Al yields 3Zn plus 2Al3 plus. Add up my voltage. So I have points. This should be negative 0.76 plus 1.66. What'd you guys get?
Or 0.9.
0.90 volts. So I would write that up here if you wanted to. This gives me 0.90 volts. Identify the species that's being oxidized. Aluminum. And let's write this short form just for fun.
Okay, so it's a solid.
It's gonna be
Al.
Al slash Al plus 3 slash slash
And then
Zn plus 2
slash Zn.
slash Zn. Nice work. Nice work. That's a good place to stop for the day.